Okay, I'm going to do a quick video on Rutherford's experiment. If you look on my channel, you'll see more in-depth videos than this if you need more information. But this one is just sort of designed to give some grade 9s an idea of what the experiment was and what conclusions were drawn from it without getting into too much detail, and basically give them sort of an idea that the ideas that we have or what we know about the atom didn't come out of nothing but came out of some specific experiments that we have evidence for. So the idea of the experiment here, it's called the gold foil experiment. And that's because he used a material a little bit like aluminum foil but made out of gold. So he took this extremely thin piece of paper, kind of like aluminum foil, and he took this new material that they had that they knew would release these things called alpha particles. What you need to know about alpha particles is that they were massive on the atomic scale, and they had a charge of +2. And he shot them at this gold foil very fast. Then he put a screen around the aluminum foil, a lot like a television screen, that would glow whenever one of these alpha particles hit it. So the idea was, based on looking at where this glow happened, he could see where the alpha particles ended up. Now, Rutherford used the analogy that this was like taking an elephant gun and shooting it at a piece of paper. The idea there being that these alpha particles were huge and fast, and basically what they should do is rip straight through the piece of paper and go and light up the screen on the opposite side. And that's fine, and that's what he noticed happened the vast majority of the time. Most of the time, the alpha particles went straight through. But something strange did happen. Every once in a while, the alpha particle would bounce straight back. This would be very rare. But it was puzzling. Like he said, this is like taking a gun and shooting it at a piece of paper and having the bullet bounce back. It's just not possible. What he figured out from this experiment was that matter was not made up of this uniform plus material substrate that they had previously thought, with these tiny little electrons floating inside. Sometimes this is called the plum pudding model, a popular food in Britain at the time, but maybe a better example now would be like a chocolate chip muffin, where you have the muffin part being the positives and the little electrons being the chocolate chips. So this is what they thought at the time, and this didn't make any sense with this experiment, so that was bad. That's the Thomson plum pudding model. Instead, there must be something incredibly massive in that piece of gold that alpha particle hit and bounced back. The way I think about this is a little bit like, imagine that the person who was baking your chocolate chip muffin had a ring on, and that ring had a little diamond in it, and they weren't paying attention, and the diamond fell and landed in the batter. Now imagine you're eating your chocolate chip muffin, and all of a sudden, crunch, you bite onto something that's incredibly hard, and it chips your tooth. Now, the muffin and the chocolate chips are not hard enough to chip your tooth. There had to be something incredibly hard in there, harder than your tooth enamel, to allow that to happen. And that must be that little chunk of diamond. What Rutherford discovered is, in order to be strong enough to make these alpha particles bounce back, the piece of material that they were hitting must be incredibly small and incredibly dense. And when he did the calculations for it, what he found was instead of it being a large sort of substrate area with these electrons, what it was instead was a series of tiny nucleuses. Now let me see if I can make my point by expanding and making things smaller again. So now this is very big, and he decided that the gold must be made up of these tiny nucleuses. and that most of the time the alpha particles would fly straight through, not hitting something, and if it hit one of these nucleuses, because they were so massive and so dense, it was able to scatter them back. The trick being here that when we look at matter, we don't see a whole bunch of little particles. What we see is a continuous material. But the idea being here that the matter is so small that when we look at it, even though these tiny little dots exist, they almost look like a continuous material. This doesn't do it justice. I probably changed those dots so that they're down to sort of the millimeter range, when really atoms exist over, a billionth of a millimeter or something like that. So it's extremely small. And so they're so close together that we can't see them apart. Kind of like pixels on your television. If you go up close to your television, you look very clearly, you'll realize that the picture on your television is made up of these tiny little dots that are all working together to create colors. But when you step back and you look at the picture as a whole, because they blend together so nicely, you don't see them. What he actually discovered, for this thing to be strong enough to bounce back what he referred to as his bullet from his elephant gun, this nucleus must be extremely dense and massive. And what that meant then is that if all the matter had to be in this one tiny little location, the next nucleus over must be really far away because there just isn't that much matter to go around. And so what he discovered also is that there's these extremely dense nuclear cores, but also most of what we look at in a material is made up of empty space. Finally, having decided that all of the massive particles within the atom must be in that tiny little nucleus, he also realized that because the charge on the alpha particle was positive, and he had seen a repulsion, and like charges repel, he decided that this was an extremely dense and massive nuclear core that was also positive in charge. Now, what we're going to talk about in other videos is how there are 3 different types of particles that make up the nucleus, and that the ones that exist in this extremely positive, dense nuclear core are the protons and the neutrons. And we're also going to discover that the electrons exist in the shells outside of that nucleus. This isn't the experiment that really discovered what was going on with the electrons. This is the one that really found that positive dense nuclear core. And again, it was like he took a gun and shot it at a piece of aluminum foil, but weirdly the bullet bounced back. And again, I like the analogy of biting into something with a rock in it. If you expected the thing to be soft and then you hit that rock, all of a sudden your teeth would get a crunch. And that crunch tells you there must be something big and heavy and dense in there. Except this wouldn't be like you chewing on a muffin. This is much bigger than that, right? That's why he said it's like an elephant gun shooting at a piece of paper. So instead of it just being like some hunk of rock or somebody's piece of jewelry that fell in or an eggshell in your scrambled eggs, it must have been something incredibly dense and incredibly strong to repel this. And that's why we get this incredibly small and incredibly dense nuclear core. Positive, repelling positive particles.